Alright, hello. We're back. On the same day as the last video, actually, in which I was saying that, true. I'm getting an Alexa reminder. I don't know if that comes through in the recording, but let me just take care of that. Very good. I was just talking in that last video about how I would like to do a bigger variety of puzzles. Because I've only really been doing Rat Run. And don't get me wrong, Rat Run is the best Sudoku series of all time. But I do want to do more puzzles because it's not going to last forever, right? And I found this one, which looked pretty cool. I found it, as in I saw it, in the Cracking the Cryptic YouTube channel today. So I'm kind of stealing it from them, but I mean, they're puzzles, right? I can't really steal them. And also it uses a new rule called Dynamic Fog, which I don't actually think is new. But I think there's just, like, more... It's easier to do now in the software here that's been, developed, Sudoku Pad. So now a lot more constructors are making puzzles for that, which is pretty cool. So, let's just get started. So, what we got is not actually a Sudoku puzzle, but it's sort of like that. We got chaos construction. Divide the grid into 9 orthogonally connected 9-cell regions and place the digits 1 to 9 once each in each row, column, and region. So in this one, we don't have our neat little 3x3 squares. In fact, this grid is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it is 9 cells large. So there are going to be 9 regions in here, but they're not going to be neat little squares. Probably. They might be something like... how many cells is that? That is 7. It might be something like that, right? So we might have a region that looks like that. But we still have to put the digits 1 through 9 in it. Once each. And then we still have to be sure that there's not the same digit in any row, column, or box. So that is how chaos construction works. It's kind of interesting. I haven't played around with it too much, but this puzzle seemed interesting enough that I could just kind of deal with it, honestly. Because the next rule is really interesting. It's dynamic fog. The grid is covered in fog. Placing a correct digit in a cell lifts fog in that cell and possibly other cells, revealing new clues. So what normally happens with fog is, say we somehow found through logic that digit was a 5. Well, if we then input the 5, it would lift the fog in there and then the cells directly surrounding it. With dynamic fog, it might not do that. It's, from the rules, it seems it's always going to lift the fog in that cell, but it might lift fog over here or something, right? It might lift those cells of fog. It might do some weird stuff. It's kind of interesting, and it keeps it really fresh. Because what you had with fog a lot of the time is that you had puzzles that they didn't really communicate very well between the grid. Like, if this was a normal cell puzzle, the only cell that we have access here to for information is the top right. So what would probably happen with most puzzles is that the puzzle would kind of start at the top left and then it would kind of propagate out in information. Sometimes constructors could get around that by implementing some interesting rules, but this is a very interesting way of doing it as well. I stopped using the word interesting. But anyway, it is interesting. I'm sorry. Squares. A digit in a square is equal to the sum of the up to 8 surrounding digits that are in different regions. That's interesting. So if we had a square here, and it was purple, let's say these cells are purple, these 2 are green, and these 2 are blue. Then that digit would be equal to the sum of these 4 digits. I think that's what that's saying. Yeah. Okay. That's interesting. CC crop key pair. I actually don't know what CC is. Anyway. Chaos construction, I guess? Sure. Crop key pairs. Digits separated by a white dot differ by 1. and belong to the same region. So say we had a white dot there. Just imagine that's a dot for a second. If this was a 4, if this is a 4, this would be a 3 or 5, definitely. And they would be in the same region, for sure. So that's what that's saying. CC successor arrows. A digit N on an arrow counts how many cells it sees of its region in the indicated direction, including itself. Region borders block vision. Additionally, the digit N+1 must appear directly behind the first seen region border. Okay. So if we had an arrow, say it was traveling like... Or, sorry, actually, arrows are going to be... I'm guessing that means that arrows are going to be just on the cell itself. So if we had an arrow in this region, and it was pointing... How am I going to show this? Let's say it was pointing up left, right? So imagine that 1 is actually a little arrow. If it was pointing up left, it would be counting how many of these cells are in the same region as it. So say it's in the blue region, and these 2 are in the blue region, then this would be a 3. And directly after the arrow ends, so there's going to be a border there, if this is all the cells in there, then this, if this is a 3, this is going to be a 4. Even if there's a blue here, if there's a region border at all, then it blocks vision. So it only sees these 3 cells. And then the 3 here means that's a 4. That's interesting. I like that. Okay. And that's it. That's the rules. I can immediately see what to do. In fact, I should have just shown this. I should have just talked about this cell to talk about successor arrows. But actually, this cell is very simple, right? It only sees 2 cells. So in theory, it can only be a 1 or a 2. But actually, it must have a digit behind a region border that it sees. So these can't be in the same region. Otherwise, the digit would be here outside the grid. So what's going on is that this is a 1. Okay, that didn't clear any fog, but I don't think that's actually wrong, because that is a possibility in this dynamic fog thing. So this is in a region. We're going to call it blue. And this is going to be in a different region. We're going to call it purple. And this is going to be a 2. Okay. So yeah, like you saw, that's cleared that region there of fog. This, I'm going to say is in purple, because purple needs to grow out. It can't be penned in. It can't be a single cell. So this is going to be in purple. This sees 1, 2, 3, 4, 5 cells. But actually, it only sees 4, because like we said, all these arrows have to see a border. They can't see the edge of the grid as their border. So this is a 1, 2, 3, or 4. It's not a 2, because that 2. If it were a 4... Okay, no. It can't be a 4, because if it were a 4, it would see these, and that they would be in the same region. But that would mean the region is purple. And then we don't see a region border. So that's not a 4. If this was a 3, then that would mean these 3 are in some region. And then this would be forced to be a 4. Oh, much easier. If this was a 1, that would mean this is in some region, and then this would be in some other region. I don't know if it's purple or if it's whatever. But it would be forced to be a 2, which it can't be because of that. So this is a 3. It didn't clear any fog. Oh, because that means these are in the same region. Can that region be blue? No, it can't. Because I think that would definitely pen in purple. So that region can't be blue. It's a different region. We're going to call it orange. And then that digit is a 4. Okay. It's getting interesting. This now has to grow. This has to grow. This... Well, let's play the same game, right? It only sees 5 cells. It can't be a 1 or 2, so it's a 3, 4, 5. If it were a 5, then these would be the cells it sees. It would be blue, but then this would be a 6, and that's not the case. So it's not a 5. If it were a 4, then these would be the cells it sees, and then that would be a 5, which is not the case. So that is a 3. And then these 3 cells are seen, I think they have to be a completely different color. Yeah, they can't be purple, they can't be blue, they can't be orange. So I'm going to call this one yellow, and then that is a 4. Alright. Now this is a square. It's kind of interesting. So let's remember what this means. The square sums up the digits in the surrounding cells, so in the 8 surrounding cells, that are not of that region. Okay. Well, first things first, that is blue, because blue has to extend out. That is now purple, because purple needs to extend out. So either it's summing up these 4 digits. Am I wrong? No. How's this right? Hold on. Oh, because I'm dumb. That's fine. For some reason, my brain's still thinking of this as 3x3 Sudoku, and I was like, there's 2 4s there, too close to each other. No, that's fine, because they're in different regions, they're in different rows, and they're in different columns. So it's completely fine. Okay, yeah. So I'm thinking about what this digit can be. Because this is at least a 2. Can this be a 1? It could. It's not on this. It doesn't see that one. So this is at least a 1. This is at least a 2. So this is at least a 3. But it'd be really useful if we knew that blue extended down here. Because then we would know that this sees 4 actually, no, my bad. Blue can't extend down there. Because if it did, look at this, then yeah, I'm being dumb. Sorry. These cells are also in a different region. So actually the minimum that this is that 5 plus that 2 there and the 1 there. So this is actually an 8 or 9, definitely. Now if blue extended down here, then now we have 4 cells in the same region. And these are gonna add up to at least 10 together. And that we can't put that there. So blue does not extend down there. So that is not blue. So that is blue. And if that's not blue, I'm pretty sure that is forced to be, okay, maybe not. That's not forced to be purple, but the point is it's not blue, I think. Okay, well here's something. This must be a 1, because if it's not, it's at least a 5, and then we have already 10. So this is a 1. Okay, that gives us another square. This is a 2 or 3, definitely. And then that's going to give us what this is. Okay, no, I think this is purple for a different reason. Because if it's not, if it's some separate region, if it's like green, I'm going to need more colors, but whatever. If it's like green, then we have the minimum of these are 1, 2, 6, 8. That's going to be forced to be a 1, and it can't because it sees a 1 there. So that is purple. Which is going to give us what? I don't know yet. That sees those squares. And it's counting at least these 3, maybe those 2 as well. If it's counting that, I think that's restricted. A little. Because this can't be a 1, 2, 3, or 4. So the minimum it can be is a 5. Then the minimum this is a 2. The minimum this is a 1. So this is at least 8. So 8 is also 8 or 9. And this is a 5 or a 6, definitely. Now, does that mean these both have to be purple? One of them definitely has to be. The other, maybe not. If that was a different color, if that was like green, that could be a 1, with that being a 2, and that being a 5. No, but if that was the case, actually. Then this would be a 9, and this would be an 8. No, that would be fine, actually. Is that right? 1, 1, 4, 8, yeah. And then it would go 1, 3, 8, 9. Okay, yeah, that would work. That's a little weird, isn't it? This is an 8, 9 pair, I'm pretty sure. But I don't know how to extend that logic. We really haven't cleared out much fog at all, which is a little concerning. Both of these can't be in a different region, so one of these is definitely purple at least. Must that be purple? No, I don't think so. Actually, yes. Yeah, that I think must be purple. Because if it isn't, it's either orange or it's some other color. Either way, the minimum its value is 2. And then I think this is broken. Because this goes 2, 5, 2, 1. And that's 10. Yeah, so this must be purple, I think. Because this can't be a 1, because it sees that 1. This one might not be purple, because it could be a 1. Let's see. We still haven't put a 1 in the purple region, and it does need a 1. Can't go there or there. 1's C. Shoot. That area. So there must be a 1 in the purple region outside of that. Purple region is 6 big right now. Now orange must extend here or here. Let's see. A little confused. That is directly related to that. And then that is different from this. If that's an 8, what does that mean? Actually, if that's an 8, that's an 8, isn't it? Yeah, no, this can't be an 8. Because if it's an 8, then these 3 have to be minimized. It goes 1, 5, 2. But if that's the case, then this is a 2, which means that's an 8. So this is not an 8, this is a 9. Okay, that's correct. This is an 8. Which means that is a 2. But I don't yet know if this is a 6, or if this is a 5 with a 1 there in a different region. But that is correct. There's an arrow here now. It's seeing 1, 2, 3, 4, 5, 6, 7 cells. It's a little concerning. 1, 2, 3. Okay, but we can get rid of a few of those options. It can't be a 2 or 4, so it's 1, 3, 5, 6, 7. It can't be 7, because then it would go 1, 2, 3, 4, 5, 6, 7, and that would be forced to be an 8, which it isn't. It can't be 6, because it would go 1, 2, 3, 4, 5, 6, and that would be forced to be 7, which it isn't. So this is 1, 3, or 5. If it's a 5, this would go 1, 2, 3, 4, 5, and that would be a 6. That could be the case, actually. Oh, this can't be a 3 or a 1. I'm very dumb. If this is a 3, it would go 1, 2, 3, and that's a 4, which it can't be. If it's a 1, that would mean that's a 2, which it can't be. Okay, so that's a 5. The successor arrows are actually really powerful, which, if that's a 5, that means that's a 6. Doesn't clear any fog. Are you serious? Is this a separate color? Yeah, this definitely can't be blue, yellow, or... Can it be orange? No, it can't be orange. Can it be orange? I think it could actually be orange. Because it could be like that. That could be the region. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, this could be orange. That's a scary thought. What is this square now? This is not 1, 2. Could be 3. 4 is taken. 5, 6 is taken. 7. This is 3, 5, or 7. If this is orange, then it's like that. And then that would force us... Oh, but it's not, because then this would be at least a 2, and that would break this square. So this is not orange. This is a new color. I'm going to mark it red. How many cells does this have? 1, 2, 3, 4, 5. Okay, well, we definitely have to extend our purple to this square, because if we didn't, if purple ended here, then purple would go down here, but then it would be confined to this little area. Or this little area? Either way. This little, actually. It would be confined to this area, but then it couldn't have a 1 in it, because 1 sees both of those. So, purple definitely extends at least there. That's 7 cells. This is also a 3... Oops. This is also a 3, 5, or 7. So, that's not a 1 yet. We do still need to get a 1 into purple somehow. And we've already used up 7 cells. So there could be a 1 there. There could be a 1 here, or here, or here. It's one of those 4, I think. I'm not gonna pencil mark that. But, yeah. Okay. Well, now blue must extend, definitely. Now what? I don't know, actually. I thought this was gonna clear out some fog. It didn't. Are we still... We're still good. So what are we doing? Good question. Orange. How far can orange extend? Can orange get out there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Orange can't get out of this little area. Even if it travels as fast as it can, it's definitely going to be confined to there. I don't know what that means, but that's something, I guess. Oh, here we go. This is a different region now. This is not purple. Which means that way of forming the 9 was actually correct. So this is a 5, this is a 1. That did clear fog in that square, I'm pretty sure. So that is correct. Does that make sense? 1, 1, 2, 5. Yeah. And then this 8 is 1, 1, 2, 4. Yeah, okay. Well, now there's a 1 there, which means none of these squares could be a 1. So I'm pretty sure it's now pretty difficult. Yeah. Ooh. It's hard. It's hard. It's hard for purple to get a 1 now, but it must get a 1 somehow. And I think, yeah, the only way it can get a 1 is if it travels straight down and gets a 1 from there. So I think these are both purple, and now that's a 1. That did clear fog, so that is right. That is a 3 or 7. Can't be a 5, so this is a 5. Oops, 5. Okay, and then we get another arrow here, which is cool. This is a 2, because it only sees... No, actually, my bad. It sees 1, 2, or 3 cells. So this is a 2 or a 3. It can't be a 1 because of that. This is not a 3, because then that would mean these 3 cells are the same color. They would be red. And then this would be a 4, which it can't be. So this is a 2. It is the same color as that, so it's red. And then this is a 3. That's a 7, and that's a 3. We are clearing out some fog, which is good. I can't tell if that's... Well, no, that's not red. That's the definition. In fact, I should be marking these region borders a little better. Kind of understand what's going on. That is the definition of these successor arrows, is that they mark a border. So that is not red. Definitely some other color. Must... Well, actually, 1, 2, 3... Yeah, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Purple's done, so we can actually delineate purple. Purple is a completed region. What I'm thinking is, must this... Actually, it can't be orange, because orange already has a 3. So it must be a new color. I'm going to call it green. And now, I'm pretty sure green is going to have to escape from here. Because if it doesn't, there's definitely not a third color in this little region, because that's way too many cells to put. If orange and green don't escape from here. And if orange escapes from here, then, like we said, it must take these specific cells. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. But then green would only be left with 4 cells, and it needs 9. So green definitely escapes through there. There must now be a 3 in this column. It can't be there, because green already has one. It can't be there, because Sudoku, and it can't be there, because Sudoku. So there's a 3 there. This is getting interesting. Orange is now stuck in this little area. It's now pinned in here. Can I definitely paint something orange then? Is there something that must be orange? Well, how many cells are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. 11, so 9 of these 11 cells must be orange, but the green needs a path to escape. Well, that path is going to be this, and then we get left with just 9 cells. So those are all orange. These are both green. Green escapes through there. And now, well, now orange needs a 2 and a 4. They can't be anywhere in there because of those. So 2 and 4 for orange are here. Which is cool. I'm liking this puzzle. This is very interesting. I don't know where to go from here specifically, but let's see. This has 6 cells in it. It needs 3 more. This has 5 cells in it. I should keep delineating my regions to understand what's going on. I don't understand what's going on. Let's see. Can I look at the ones really quick? Okay, so ones right now take up this entire, like, top right of the grid. Not that, actually. They take up a good amount of the top right of the grid. Plus that cell, because the blue already has one. It's going to be a little difficult for yellow to get a 1 now. It's either going to be somewhere down here, or it's going to be in this row. That's probably where it'll be. But I can't be sure of that yet. Is there any other numbers that we have a lot of? 3s we have a lot of. Let me see what 3s cover. We have how many? 5 threes? We have 5 threes. We need 4 more. Don't know. Blue needs a 3 still. It's gonna get it from this little region over here, because it can't get it from down there. Definitely not, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it can't even reach this bottom part, so it's gonna get it from these cells up here. The blue 3. These cells, I can mark them. They are 2, 3, 4, 5. Let's say, oh, there we go. That's a 6. That's a 5. Oh, and an arrow. Whoop-dee. This is either 1, 2, 3, 4, 5. It's not a 3 or 5, so it's a 1, 2, or 4. That was a 1. That would be a 2, which it can be. That was a 2. That would mean these are in the same region, and then that is a 3, which it can't be. And if that was a 4, that would mean 1, 2, 3, 4 are in the same region, and that's a 5, which it is, actually. So that would make sense. Oh, but that wouldn't make sense, because 1, 2, 3, 4, that would mean that they're in the same region, but then there would have to be a border here, and there isn't. So that is not a 4, that is a 1, which means that is a 2, which does give us a square there. Now, I don't know if that's green is the problem. Can this be red? Because that is definitely not green. If this is green, then that's not green, because there's a border here between the 1 and the 2. Can that be red? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, red can't reach that. Green can't reach that. No other color can reach that. So that is a separate color. I'm gonna call it. No, we're not gonna call it gray. We're gonna call it purple. So that is purple. That is a new region. This is definitely not purple, but I don't know if it's green is the problem. So there is a border there, but I don't know if this is green or if that's a separate color. How many colors do we have so far? 1, 2, 3, 4, 5, 6, 7. Okay, so we're running out of regions. We only have 9 regions to play in. We don't have too many of them left. We have the square here. It's counting the sum of these 4 cells, whichever ones aren't in this region, in green. Right now, it's at least a 5. It can't be a 5 because that's 5, so it's at least a 6. It's not a 6 because that's 6, so it's at least a 7. So it's a 7, 8, or 9. Definitely. If it's a 7, yeah, if it's a 7, then this is in a separate region from green. Because there's no other way of making a 7. We already have 5, so we need 2 more. Can't put 2 1s in there, because that can't be a 1. So we need a 2. None of these can be a 2, so that would be forced to be the 2 that we're counting. So that would be in a completely separate region. It would be like brown. And then green would get out through here. And that would work. If this was a 8, then these 3 cells, whichever ones aren't in the region, have to sum up to 3. That can't be a 1, 2, or 3. That could be a 3. But if it was a 3 alone, then that would mean these 2 are green, and this is brown, or purple, or whatever. It's not green, but then green is too small. It would only have 7 cells in it. So, if this is an 8, then that's a 1. And it's in a separate region. It's in the same region as this. They would go together. Oh, but they would also pen in green. Green would be too small still. So that's not an 8, is what that means. If that's a 9, then these 3 cells together, the ones that aren't in the region, have sum up to 4. This could be a 4, with those 2 being green. And then this would actually be forced to be red, because it can't be a new color. That would work, actually. This would be a 1 or a 3. Yeah, that would work for this to become a 9. Something else work? No, that would be the only way. So, what did we find out? Okay. Well, we found out something that I should have said before, I think. 1, 2, 3, 4, 5, 6. Yeah, we only have 6. No, sorry. 1, 2, 3, 4, 5. We only have 5 cells in here right now. So whatever happens, even if we take both of those cells, and just forget about the square for a second. 1, 2, 3, 4, 5, 6, 7. We're definitely going to escape through there. So that is great for sure. And that makes things much easier. That being green means this can't be a separate region because it would be a 1 cell region. So that is green. And that being green means this is not a 7. This is a 9. And that is a 4. And that is red. Great. Very good. So let's draw in some more borders. That's all. We have another arrow here. Let me think about green for a second. No, that's all. That's all I can do with green for now. I can mark these. These are big digits. These are 6, 7, 8, or 9. They're not 6s. In fact, where are the 6s right now? There's not too many of them. Red needs a 6, but it can get one pretty easily still. It has 1, 2, 3, 4, 5, 6, 7 cells. It can get 2 more. It will get 2 more, in fact. Let's look at this digit. So this is a 1, 2, 3, 4, 5, 6. It's not 4, 5, or 6, so it is 1, 2, or 3. If it's a 2, that would mean these are in the same region. That doesn't necessarily have to be purple, but they're in the same region. We'll call it brown. And then that would be a 3. I guess that's possible. If this was a 1, then this would be in a region. This would be in a separate region, which is probably purple, but for now let's just call it I don't know. I don't have any colors up. We'll call it pink. Like light pink, I get tuna, whatever. Salmon color. Whatever. If this is a 1, then that's a 2. Which it could be. It might be purple, it might be whatever. If this is a 3, then these are all in the same region. That region is... Whoopsie daisy. It's green. And then this is a 4, which it is. It definitely is. Does that make this region too big? 1, 2... Oh, this can't be a 3, actually, because that is already a 3 in that region. So this can't be a 3. This is a 1 or 2 now. Which means either this is a 2... Oh, that can't be a 3, because there's already a 3 there. So this is a 1. This is a 2. They are in separate regions, but I actually don't know what those regions are. This might be purple. This might be green. This might be a completely different color. I don't know. Can it be a completely different color, or must it be purple or green? If this is a completely different color, let's say this is brown, then it is penned in here, so that it must extend up. But then 1, 2, 3, 4, 5, 6, 7. Green must extend up there to complete itself, and now red is penned in. And now it has 8 cells. So this is not a completely different color. This is green or purple, for sure. And it's not green, because green already has a 2. So it says purple. It's the purple 2. This is not purple, because purple already has a 1. It can't be green, because green can't reach there. It can't be red, because red can't reach there. So this is a new color. We're finally going to actually get the brown. We've been teasing it for a while, but finally arrived. Okay. Now what? Well, green must extend, because green must escape. Green now has 8 cells, so it needs 1 more. Red must extend, so it must get out through there. Green must now extend here. Purple must now extend here. Okay, we're getting something. So let's fill these squares in. These are 1. Oh, well, there's the 1. There's the green one. These are 3. There's the green 3. 4 and 7. 4 is not there. 7 is there. These aren't 7s now. Red needs 1, 2, 3, 4, 5, 6, and 7. Yeah, to fill itself. Square. Interesting. How many colors do we have now? 1, 2, 3, 4, 5, 6, 7, 8. So we only have one new color to introduce. And this cell doesn't see that many things of different regions. In fact, it needs to see one more. This can't be purple. Because if it is, then this only sees one of a separate color. So this would be forced to be a 1, which it can't be by Sudoku, by regions, by everything. So this is not purple. So there is a border here. There's a border there. Let me draw these in better. This region's completed. This region's completed. This is a separate color. I don't know if it's brown. It could be the 9th color. But it is a separate color, which means purple's gonna have to come in through here. Purple's gonna have to come in through there. Purple's gonna have to come in through there. This is a border, so that still can't be purple. Purple now has 7 cells. Okay. This area of the puzzle's still pretty empty, but I'm sure it'll fill itself up in a jiffy. Jiffy, what? This cell is that plus that. So it's that plus 1. I think that actually has a hard time working. That can't be a 1, 2, 3, 4, 5, or 6. So that is a 7 or an 8. And this is an 8 or a 9. It's not a 9, so this is an 8. This is a 7. Again, I don't know what color this is, but that is an 8 and that is a 7 for sure. In this row, what is left? 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that can't be an 8 because it's in purple. So this is a 9, this is an 8. In this row, what is left? 1, 2, 3, 4, and 6. That must be 6 by Sudoku. These aren't 6s. 1, 2, 3, 4, 5, 6. This square is from 5, 6, and 7. Don't know which yet. These are from 7 and 9. Okay. We're getting somewhere. I think it's gonna slow down a little bit. Because I don't know where to go. Well, let's think about this. If this was our 9th color, we'll call it salmon. Then salmon has to extend up. Brown has to extend up. Brown has to extend up. Salmon has to extend up. That would force purple to go here, and that is 8. That would force purple to go here. It would close itself. Salmon has to extend up. Does that work? I don't see why not. These are 5, 6, and 7. That can't be a 6 or a 7, so that would be forced to be a 5. These two would be 6 and 7. I don't really see the issue with that. Or this could just be brown. And that would be much more boring. But, I mean, it's probably what's gonna happen. I don't know how to prove that, though. This is 6 or 7. Oh, sorry, actually. These two, I didn't see it, there was another cell there. These two are 1, 2, 3, 4, 5, 6, 7, and 8. That's not an 8. That's not an 8. So that is an 8. This is 6 or 7. Was the puzzle good? The puzzle's not good, dude. What do you mean? What do you mean? What did I fuck up? What? I fucked something up all the way back there? What? When? How? What do you mean? The fog was clearing. Oh, I'm very dumb. There's already a 3 in here, dude. Sorry. Wrong pencil mark. 1, 2, 3, 4. Which means a 4 goes there. 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Ah, sorry. My bad. That is how that goes. This must still be the same logic. Yeah, this must still be the same logic. That's an 8, that's a 7. That's an 8, that's a 7. These aren't 7s. Are we good now? No? What do you mean, dude? Okay, hold on. This is not purple. There's a border there. So purple extends through here. There's a border here. So purple extends through there. That is still correct. For sure. So that is a separate color. It can't be 1, 2. Oh, but now there's not a 3 there. So this could actually be a 3, with that being a 4. 4, 5, 6, 7, 8. 8, 9. Okay, this can't be a 9, so that can't be an 8. This is a 3 or a 7, this is a 4 or an 8. Okay, so it does make it a little different from last time. My bad. I'm sorry. I screwed up. It's fine. Look, it's late, alright? Excuses. 6, 7, and 8 here. That's not an 8. This is 6, 7, 8, or 9. To fill in that region. This region needs 6, 7, 8, or 9. That can be a 6. Can this be a 3? Yeah, so 3 is in one of those two in this row. Still good? Still good. Gosh, I'm sorry. 4 is in here. So it is in the purple region. What can I do with that? If 9 is not there, then 9 is here. I don't think that changes anything drastically. That is in a separate region. Can I now prove that that's not salmon? Because now salmon must extend up. Brown, brown, salmon, purple. Purple. Purple would be completed. Salmon extends. Don't see the issue with that. Fortunately. Is there some digit here that can't be put in here? No. All digits are possible. Or again, that could just be brown. That also works. Okay, I'm a little stuck. I'm not gonna lie. The puzzle's correct, as it is right now, but... yeah. Let me look at ones really quick. Maybe it's Sudoku that we have to think about. Sudoku's a little strange. With these... oh yeah, it is Sudoku, well, actually. I just have to figure out where the Sudoku ends up. Because we have 8 ones, so it should be able to find the 9th one. Those spots are all covered by 1s. That is covered by 1s. Wait, did we have 8 ones or do we have 7 ones? Oh no, we have 7 ones. My bad. Well, still, redraw that, by the way, really quick. So that is the area that's covered by 1s. So there is a little X-wing of 1s in these cells. Kind of interesting, but not puzzle solving. Sudoku is really hard to implement in these chaos puzzles. That's the problem. Do they even have a 7 on the board? I have 1. I have 1 8, 2 9s. Yeah, it's not gonna be helpful. Weird. There's a 5 in this region. It's not in any of those. So it is up here somewhere. In purple. That's an 8, that's a 7. That's a 4, that's a 3. Either way, that is a separate color from purple. I don't know where to go from here. Maybe I need to look up here somehow. Yellow is still very small. It's only 3 cells. Blue is still only 5 cells. I don't know how to extend them, though. I don't know if I can. Actually, well, yellow still needs a 1, so it's definitely going to get it from there. So one of those is yellow, and yellow extends to there, at least. It can't get it from here, because it can't go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it can't reach that. 1, 2, 3, 4, 5, 6. Can't reach these ones down here, so it's going to reach this one, whatever that is. So one of those is yellow. Definitely. How many colors do we have? 1, 2, 3, 4, 5, 6, 7, 8. There is still a 9th color that needs to be introduced. Where is it going to be? Is my question. That 9th color needs a 1. Oh, that 9th color needs a 1. So it's going to get it from there. So that is salmon. Whatever cell here has a 1, it is salmon colored. Can that be salmon? If that's salmon, then it's not purple, so purple must go here. But now purple has 1, 2, 3, 4, 5, 6, 7, 8 cells. It can't do that, or it's going to pin brown in. So it must do that. But we said that that's not purple. There's a border right there. So that can't be salmon. That is salmon. Oh, that's smart. I like that. Which means that's a 1. And then this is a 1. And it is yellow. That is smart. I like that. That's really cool. Oh, white dot. We haven't seen one of those yet. That I almost forgot that rule existed. White dots belong to the same region. So that is purple for sure. 1, 2, 3, 4, 5, 6, 7, 8. There's one more purple cell. This is like that. That's all our 1s in the puzzle. That is what? Good question. If that's purple, then that is the last purple. So none of these are purple. Purple would be finished. And then this would be summing up those 4 cells. The minimum of that is a 2. The minimum of this is a 2, 4 pair. So this would be at least 1, 2, 3, 4, 5, 9. This would be forced to be a 9, actually. If that's purple, that's a 9, for sure. And these are all... Oh, my bad. This can't be 2 2s, right, on top of each other. So this would actually be minimum of... let me do it backwards. This would be a minimum of 2, 4. And this would be a minimum of... 2. Oh, that would actually work. If it was like this, that would work. So this... If this is purple, this is definitely the case. of these 4 cells. None of them are purple, and they are these numbers. Exactly. If this is not purple, then what the heck is it? I don't know. It can't be blue. It can't be orange. Or brown. Can it be brown? No, it can't be brown, or it's going to pin in the pink. Can it be yellow? 1, 2, 3, 4, 5, 6, 7, 8, 9? No. So it'd be forced to be salmon. If it's not purple, it's salmon. But then purple is penned in, so purple must extend there. That is the last 3, 4, 5, 6, 7, 8, 9. That would be the last purple cell. This would be forced to be brown. Those would be brown. That would be tan. Or, I guess tan is a good word for it. Sure. And now this would be summing up whatever of these 3 aren't tan. There's a lot of options for that, actually. Are there? Not really, actually. Because now, this is a minimum of 2. These are still a minimum of 2 and 4. So the minimum this would be is 2 plus 2 plus 4, which is 8. So either way, no matter the color, this is an 8 or a 9. Definitely. Or no, sorry. My bad. These could be tan still. These don't necessarily have to be a separate color. That's annoying. Okay, let me go back. We were here. Yeah, this is where we got to. These are consecutive. These are consecutive. This can't be a 1, 2, 3, or 4. This is 5, 6, 7, 8, or 9. So this is 4, 5, 6, 7, 8, or 9. That's not helpful at all. That's not helpful at all, dude. This is a 4 or an 8. How does that help me? I don't know. This is purple or tan, definitely. Because we proved it, right? This has to be purple or tan. If this is purple, that is 9, and it's that configuration of digits we set. If this is tan, it's 8. It's not necessarily 8 or 9, because these could be 10 as well. Whoa, it's getting difficult. It's getting difficult to think about, dude. In this row, there must be a 2. It can't be there. Can't be any of those. Can't be there. Can't be there by Sudoku. So it's in one of those 2. Don't know which one. There must be a 4 in this row. Can't be there. And it could be there. It's in one of those 3. What else is left in this row? 5 is left. 5 isn't one of these 3. I don't know what to do with that. 1s are done. We have all 9 of our 1s. Oh, here's one thing we can say. That's definitely brown. Because brown must get out of this little region it's in. If that's not brown, brown is penned in. So that is brown. That is brown to connect them. These might be brown. Actually, that must be brown now. That doesn't. No, that could be tan. Tan could be going like this. But those 2 are definitely brown. Which does mean this one is tan, at least. Because if it isn't, then tan is penned in. So tan goes there, at least. Does that now mean this is purple? No. No, it doesn't. This is tan or brown. Definitely. It's 3 or 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Barely. Okay. I was thinking if this could be purple, because if it's purple, these two are in a different region than purple. But then this would be forced to be a 2 from what we said, but this would be forced to be a 2, so that couldn't be tan. But it could be yellow. Yellow could extend all the way down there like this, and get a 2 there. Unlucky. Okay. Oh, 9 is definitely in here in this column, because it's not there, so that's not a 9. Small victory, but something. One, 2. There's a 3 missing in this row, so it is in one of those 2. There's a 4 missing, it's in one of these 3. There's a 5 missing, which is in one of these 2, so these are actually a 3, 5. That doesn't make sense. 5's already there, my bad. 3. Oh, gosh, I'm getting a call. I'm so sorry. Okay, I'm back. My bad, I got a call. I just realized something. Yeah, I got a digit. There must be a 3 in this row, so it's in one of those 2. It can't be there, because there's a 3 in there. So this is a 3, which means this is a 4. This is a 7, 8, or a 9. There's a 3 in there. It can't be there now, because of Sudoku, so there's a 3 here. Oh, an arrow. Oh, 3 in the corner, by the way. That's fun. An arrow. We've been saved. Okay, so this is 1, 2, 3, 4, 5, 6, 7. It's not a 1 or a 2, so it's a 3, 4, 5, 6, or 7. It's not a 4. Okay, let's think about what this can't be. Well, this can't be a 7, because this would mean 1, 2, 3, 4, 5, 6, and 7 are all in the same region, which they definitely are not. I don't think this can be a 6. 1, 2, 3, 4, 5, 6. It also can't be a 5. Okay, this is a 3. Which means 1, 2, 3 are in the same region, so those are all blue. And now this is a 4. And now that's a 2, that's a 4. Okay, we're getting somewhere. This is a border. So this is... yeah, this is definitely tan or purple. Or brown, my bad. I don't think it's... 3, 4, 5, 6, 7. I don't think it can be tan. Because if this is... gosh. Golly gosh. Okay. If this is tan, then tan must get out through there. But now these 2 tan regions must connect. No, that actually does work. 1, 2, 3, 4, 5, 6, 7, 8, 9. If those were all brown, that would be the brown region. And then this tan could go 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, it doesn't work. Yeah, I think if these 2 connect, they're gonna pen in this brown. So this, I don't think is tan. I think this is brown. I still don't know if that's tan or brown, but I think that is brown. This blue region now has 7 cells in it. These are from 5, 6, 7, 8, and 9. This can't be 5, 6, or 9. This can't be 5 or 7. Okay. It's getting a little weird. This must be brown, definitely, because it can't be a separate color, otherwise it would be penned in. So brown now has 6 cells. Maybe 7. That must be brown or tan, definitely. No, sorry, it could be purple still. My bad. Yeah, I still don't know still don't know what this is. No, I do. I now do, because now this can't be a 2, because of that 2. So the minimum this is a 5. Yeah, this can't be purple. Okay, so that is tan. Purple goes here instead. Purple is completed. I have not been marking my regions, which I should be doing. That's actually it. That's all the marking I need. Okay. Goody goody. This is a 7, 8, or 9. It's not a 9, actually. Which means... Sorry, this is 6, 7, or 8. My bad. We good? Yeah, we're good. Woofa. Thinking about what this is. I don't think I can figure it out yet. There's a 5 in this region. It's definitely one of those. If 5 is here, it goes together with the 6. So it'd go 5, 6. Then these would be 7, 8, 9 triple. Or 5 could go in there. And then nothing. And then nothing interesting happens. Oh. Here's something. These can't both be tan, because if they were, this would be counting that, and these would be the same digit. So these can't both be tan. Can either of them be blue? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Can either of them be brown? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Barely. They can barely be brown. That's annoying. Well, if they were, it would be this one. So that would be brown. Now, it has to connect to its friends in 2 cells. So that has to be brown. Tan would be forced to escape through there and then through there. The minimum in that square is a 2. Right? Yeah. No, I'm out of breath. Good lord. Don't know. Too complicated. I don't think that's what we're supposed to think about. It could also be the case that this is a yellow. Can both of these not be tan? If both of them were not tan, then tan has to escape through there. So if both of these are not tan, there's a border here. So tan must escape through there. Then brown must escape through here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would work. Oh, here's something. Much simpler. This is now not tan. So this is definitely brown. So brown now does have 7 cells, for sure. Brown must get a 2. What are 2 situation looking like? We have 6 2s on the board. What doesn't have a 2 yet? Purple, brown, and... Wait a second. No, purple has a 2. Brown, tan, and yellow don't have a 2 quite yet. There is a 2 in there. In that case... Oh, it's right there. There we go. These are from 5, 6, 7, 8, and 9. That's not useful. Never mind. 5 is definitely there or there in this row. Don't know which. What is this? This is at least a 5. But this is at least a 5. And I'm adding something to it, so this is at least a 6. No, but I'm not adding 1 to it, because all the 1s are taken. So this is at least a 7, I think. So 5 and 6 must go in here somewhere. Don't know. Because this could be a 5 here, and then a 2 here. Or a 2 here, and then tan escapes through there. Yeah, that would work. So this is from 7, 8, 9. I'm pretty sure of that. Am I missing something like obvious? What? Well, that definitely has to be yellow. Yeah. Yeah, there's no other color that can be. That's yellow. In fact, I think this yellow just has to connect there. Yeah. Yeah, that yellow has to connect. 1, 2, 3, 4, 5, 6, 7. Okay. Oh. Yellow still needs a 2. We're gonna get it. Sorry, I need to visualize this better. Let me mark what the 2's, what the region of tunage is. Yeah, yellows must get a 2 from one of those. 1, 2, 3, 4, 5, 6, 7. So there is a yellow 2 in one of these 3 cells. Definitely. I don't know where. Tan still needs a 2. Is there 7 2s on the board? Yes. Yeah, so 2s can only go in there. One of them is tan, the other is yellow. I don't think that can be a tan 2. Because then yellow would be forced to get a 2 over there, and it can't. But that's, I think, the only thing I can really say, unfortunately. One of these 3 is a tan 2, and one of these 3 is a yellow 2. What about 3s? How many 3s do we have? We have a lot of 3s, actually. Oh, we have 8 3s. Okay, so we should be able to find the last 3. It's in this row, and this column. It's right there. Oh, huge. Huge? Maybe. Maybe huge. No, yeah, huge. Huge for sure. Maybe. Hold on. This is a 2 or 4, for sure. And they're in the same region. What is that region? I think it must be tan. Because if it's yellow, yellow already has 7 cells, so that would be 8 and 9, but they're not connected. Blue already has 7 cells, so they are not connected. And brown already has 7 cells, and they're not connected. So those are tan, definitely. Does that mean that has to be a 2? No, not specifically. Does that mean that has to be tan? Yeah, I could have gotten that earlier, actually. That must be tan. Right? Yeah, because it can't be any other color. None of the other remaining regions can get there. So that is tan. Which now means the yellow does go into one of these 2 cells to get its 2, so that is yellow. Yellow now has 8 cells. Tan has 6 cells. Can I say what that is now? Finally? Don't think so. Somehow. How many 4s do we have? Let's keep checking some Sudoku. We have 7 4s. So we should be able to delineate an area where 4s can be. No, none in there, none in there, none in there, none in there, none in there. None in here, none in here. So 4 is also in here. The 2 4s also form an X-wing in there. So these squares are all from 2 and 4, actually. Which means something, for sure. That's a 6, 8, 9 triple. That is a 7 or an 8. Now what? Can that be a 5? It could. 5 is in one of these 3 cells. Don't know which. These... no. Yep. I don't know how to finish off this one. This is a little hard. How long have I been recording? 1 hour 16 minutes. Not terrible. My mic's on? My mic's on. Good. You never know. You never know. What am I doing here? Oh, I'm silly. 7, 8 pair there. Means this is 6. This is a 9. That gives me a lot of stuff, actually. I don't mind. Doesn't give me that much stuff. But it gave me a little bit, which was fun. Oh, I can get this. This is 1, 2, 3, 4. This is a 5. Oh, which is huge, because now that can't be a 5. So in this column, the 5 must go there, and it must go together with a 6. There we go. So it must go 5, 6. That's not a 6. That is a 7, 8, or 9. That is a 7, 8, or 9. Is that right? That's right. That's not a 6. 6 in this column must go there. 7, 8, 9 triple puts a 5 here. These are from 6, 7, 8, and 9. That's not a 6. There must be a 5 in one of these two. It's not there by Sudoku, so it's there. 6, 7, 8, 9 quadruple gives us a 5 there. Oh. Oh. Mamma mia. Okay. There's a white dot there. That's kind of crazy. There's a little crazy. It can't be a 7, 8, because that would make that invalid. But it contains either a 6 or an 8. Because a white dot must always contain an even and an odd number. So one of the 6 and 8 is there. The other's there, so that can't be an 8. That's a 7. That's an 8. These don't have 7 now, so they're not 6, 7. They are 8, 9, which puts a 6 there, 8 there, 7. Oh, this is going to clear up absolutely nothing. I thought it was going to do a lot more than that, honestly. I was ready for it to do a lot more than that, and it just didn't. And that kind of pisses me off. These are 6, 7, 8, 9. That's not an 8. These are 6, 7, and 9. That is a... That's a 6. I was just a 6 rattling. Okay. Now what? Great question. What the heck am I doing now? 1, 2, 3, 4, 8, and 9 are taken. Wait. 1, 2, 3, 4, 5, 6, 7. Oh, I did something wrong. No, I didn't. Really? What? Oh, yeah, of course. Okay. This brown region needs a 7. So that is it, right? That's the only 7 that we can get. So that is brown. That is brown. So the brown region's completed. Finally. This can't be yellow, because yellow already has a 5. This can't be tan, because tan already has a 5, so this is blue. 1, 2, 3, 4, 5, 6, 7, 8. Blue must get that cell. Blue already has a 9, so that is a 7, which means that's a 6, 9, 9. Not a 9. These aren't 9s. That's not a 6. 7, 8 pair puts a 6 there. Okay. These are both tan, because they're not anything else. This is not yellow, because yellow already has a 9, so that's tan. And that is yellow. And that finishes off our coloring. Now we just have to finish off the numbers. And it's gonna be that cell, isn't it? Yeah, because that is now not an 8. Because this is 5 plus 2 or 5 plus 4. So that is not an 8. Which means what? Oh, it's not a 9, because 9 already exists in that region. So that is a 7, which means that's a 2. 4, 2, 4, 8, 7, 8, 9, 8, 9, 7, 9, 8, 9. Oh, golly gosh. Oh no. Did I break it? No. What? How does this resolve? Because we have an X-wing of 7 8s here. How is this going to resolve? Oh. Red already has an 8. So that's 7, 8, 8, 7. Wow, there we go. Ho, ho. That was fun. That was fun. Let me mark these. Did I mark these two with a wrong blue? I did. That's funny. There we go. That's pretty. I like that. That's a cool puzzle. I like that a lot. Yeah, these chaos construction puzzles are actually pretty cool, where you have to like make the regions yourself. They're pretty fun. A lot of times they have really interesting rule sets, and I love the use of dynamic fog. That was really, really pretty. We had a few mistakes that I made here and there, but it's okay. We live through those. I like that. I like that a lot. That's really fun. That is a good rule set, I think. That is very, very nice. I like the use of squares. There's not that many of them. There's only 5 of them. There's not that many Kropke dots. And this one wasn't even used to figure out regions, because I already had the brown region on this when I got that square. It was just used to figure out the numbers. Yeah, that was fun. I really enjoyed that. I liked that moment right there where I had to figure out that that was a yellow 1. That was really smart. It was a really smart construction. I enjoyed it. It was very good. Let's see what we need to do here. Row 1, left to right. That would be 214, 753, 968. 214, 753, 968. And there we go. Very cool puzzle. I enjoyed that quite a bit. Took me an hour, 20 minutes. Honestly, not bad. I saw that the Cracking the Cryptic video is about an hour long. So, obviously, they have all their other stuff that they do with intro, so I'm sure they solve, when I'm saying they, I'm sure Simon solved it quite a bit faster than I did, but still, I'm pretty proud of it, of that. Obviously, I'm playing with checking on and, like, doing that all the time. Which, again, some people would say that that's cheating. Good for you. That's how I prefer to play it. I'm sorry. Good puzzle. Good puzzle. That's really the only important thing here. So that was a good puzzle. I enjoyed that quite a bit. I guess I could delineate the outside of the grid to make it really clear that these are regions. Yeah, that's pretty. I like that. I think that's a good set of colors for it whenever I need 9 separate colors. That's not bad. Those are very distinct from each other. These ones are a little similar. I'm not sure how colorblind friendly these are. Probably not very. But yeah. Anyway, that's it. Nothing else to say really. Good night.